I hope, yes, we're live. Good. So, welcome to the second part of the discussion about what the unit tests are desperately trying to tell you when you write them about your production design. In case you didn't saw the first episode, the first half of this, it's on YouTube already. Check out my website, and from there, actually, you can Google me, and I have a YouTube channel. It's posted on my YouTube channel, the first part. I will try not to overlap with the first part, so if you didn't saw it, please do afterwards. Good. Now, it's correct to start to tell you who am I again. That's the story. My name is Victorrenta. I'm a Java champion. I'm writing Java for many years. I'm doing right now trainings for a living in different companies. My topics are Spring, Hibernate, functional programming with Java, architecture, domain-driven design, refactoring, TDD, unit testing, and this is where I will cherry pick the stuff. I am cherry picking the stuff I'm showing you right now. Performance reactive programming and secure coding. This is what I'm doing every week, basically. And also I'm doing talks at different conferences, and to my beloved Bucharest software craftsmanship community, who has gone wild recently. 4,000 and something. That's like, whoa, for almost 4,000. We are among the largest, I think, top 5 largest communities about software craftsmanship. And software craftsmanship is all about clean code, refactoring, unit testing, simple design, and behaving like a team and growing the technical culture. All right. Yes, good. Right, Switzerland, a lot of people around here. Good, thank you. Now, what else? If you aren't yet part of my community, please join. It's super cool. This is what I'm doing right now, to share stuff and also actually to learn from you. This is my hidden goal. I'm showing you what I know, and you answer, and you challenge me, and you come back and you tell me, hey, I see it in a different way. That's why I do this. Good. Then I have a YouTube channel, and I'm doing the trainings for companies. I go there, and I don't know, 20 people, 15 people, 15 developers in a group. But I also started doing open classes for everyone to join. These are paid, but you can join people from different companies for more niche topics like this, for which is hard to get a full group from a single company. You can join a mixed group with other companies. And I also have some video lessons on Teachable. That's it, done. All right, so last time, I will just very super briefly repeat what we did back then. I started asking if you are agile, and Agile came with the idea that you should eventually refactor your architecture to something better, but then that never happened. And it's the emergent architecture that never emerges because we keep rushing and we don't ever stop to rethink the design. Then the tough question, if you write the tests before the implementation, probably not. 80% of you probably not. But the point is that writing tests before the implementation not only gives you more coverage, but gives you design feedback, and that's the topic for this presentation, basically. Now, mocks are always in the discussion about testing, because they allow us to write tests which are repeatable, fast, super fast, and allow us to tackle bits of the behavior in our production in isolation from one another. In other words, to test very complex, very cyclomatic complex parts, but slicing them into smaller parts. Now, started last time with a warning: if there's not much complexity in the feature you're testing, don't introduce mocks in between. Try to test them together, and then you get what is called a social unit test. Social unit test. If you want to spend more time on the naming things, I will have a suggestion for you for an article. I will put it right now in the chat, both on YouTube and in Zoom. It's Practical Testing Pyramid from Marty Fowler. Very good classification and with very good examples about the different types of tests that are available for us. Good. Now, what else? So the point is that the assumption for this presentation is that you have sufficient complexity to test. Otherwise, you can just test it all completely together as a whole. Good. The first design hint that tests give you is that you should take in the methods you test the exact minimum amount of information you need in the signatures. Don't take heavy objects as an argument to a method. Instead, prefer to take the individual parts that you really need. Of course, there is a trade-off here. You won't go 5 arguments probably. But the point is, don't pass heavy objects to a method that would instead just take 1 or 2 arguments from that heavy object extracted from them. That leads to simpler to understand production code and also easier to test. Good. Immutable objects are good. Some people don't need me to tell them that, but the point is that if you don't favor immutable objects, the testing can become very, very, very cumbersome if you try to emulate the behavior of changing an object. Watch the previous episode if you want to know more. So immutable objects are always there for anyone who wrote at least 500 unit tests. It's like, yeah. Look, Tom has a very good remark. Do you know what mocking means? Really, mocking in English means to make fun of someone. And he has a very nice quote. I want to put it on the screen for you. If you mock all your dependencies will mock you in production. Right? So, because, yeah, they will make fun of you. Your stuff will not work when you put it in production because you just tested stuff in isolation. Everything together. God help us all, right? Good. Now, the next point that we covered is that testing pure functions is very easy. It's been very pleasant. Pure functions are functions that don't change anything and that return the same values, the same results for the same inputs. They are a pleasure to work with. They are directly coming from functional programming, but they are a goal everywhere complexity accumulates. And I said, every time you have complexity, look, every time you have complexity, you will try to isolate, to attract, to group that complexity into a functional core, as we call it. Actually, as Venkat Subrahmanyan calls it. This functional core is a place, I mean, it's basically composed of pure functions that implement the most complex part of your logic. So it is a goal in design to make your production simpler, to implement the most complex parts of your logic as pure functions, which are easier to understand and easier to test. And pure functions don't need mocks. No mocks, right? That's a goal in design of our production systems, which leads to this separation of functional in the middle, where the complexity is, and surrounding it, of course, there is interaction with the outside world, dependencies, retrieving data, changing stuff, and that should happen at the periphery, at the boundary. This is one of the most advanced design principles in software. It's not easy, but it makes the production code easier to understand because you don't need to concern about, oh my God, what would that function do? It just returns values, relax. Right? And in tests, it's a pleasure to work with. You just give them arguments and they give you back results. Done. Right. So these were, we call this functional core imperative shell segregation. Good. And then, let me just, maybe you can help me with this. I'm not entirely sure we got that far to talk about spies. Actually, I can look in the code because the code is exactly like we left it last time. So yeah, with test spies. So that run by, nope, we didn't do that. All right, this is where we resume the discussion. Good. So correct me if I'm wrong. I didn't talk about spy last time, right? Please double check with me. I don't think I talked about spy at all last time. No, good. Now here is the thing. This is okay. From now on, new stuff, all right? If you have wait, not this. I have to roll back. Where are you? Functional point potential. Wait, separation by level. Yeah, good. You have two complex functions in the same production class, and they call each other. F calls G. Pay attention, it's not easy. F calls G. Both are complex. Now, every time there is complexity accumulating in there, you want to write your tests. You want to test them in isolation. Every time there is complexity here and complexity there, trying to test them both together requires dozens, hundreds, not hundreds, but dozens of tests, and it's not reasonable to write 50 tests for F. So now, ideally, you want to test them in isolation, so you test G separately. You test G separately, and after you put, I don't know, 7 tests on G, then you turn to F, and you say, let me test F now. What happens next? When you test F, because F calls G, you don't want F to be calling G because you already tested G. If you would allow it to call G, you will have test overlapping. And then when you change anything here, you will see fireworks. Look, ma, fireworks, right? It will blow up everywhere. Just a second. The want to test them separately. How? Because after all, they are calling each other and they are part of the same class. Let's put some code on the screen. So here it is. This is the God test, and the God class is here. Am I? Yeah, good. And we have 2 methods inside. We have a high method and a low method. You will understand why the names in a moment. And we imagine that there is very much complexity, a lot of complexity here and here. And you want to test them in isolation. So, and this is what you did. You tested low in isolation. There you go. You tested low. And you put 5 more tests. Imagine you have 5 more tests like this to justify the effort. There are many branches. You have to go through the if, you have to go through the other if, you have to loop once, you have to go through that exception out. There are many tests you need to write. Good. You tested them. Good. Good to go. But then when you want to test the other one, let's see what happens. Okay? It's what happens. Testing the other one, unfortunately, requires you turn to some very dark weapons in mocking, which are called partial mocks. I talked about partial mocks a while ago, several times already, but in case you never saw it, I have a very good video about partial mocks. Let me find it, just a second. In case you didn't notice, I'm at slide 350. So here it is, partial mock. This is it, a partial mock. It's an object that has real methods and tested methods. I mean, some of them are mocks, some of them are for real. It's an object in which you have both tested code and mocked methods. Is something insane. But let's see why. Let's take it very, 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 very easy. Why do we need it? Imagine we didn't put any spy here, and we just wanted to instantiate God without any magic around. If you just fire a test to this method, let's see what happens. To see why we got there in the first place. So you are trying to test high. So, to do that, you instantiate order and you set it a payment method card. Why? Because you want to test this if, and this if checks for payment method to be card. Good. And then return something or something else. Good. When you call the method with such an order, you will see an error, a null pointer exception. And you will wonder why in the world, what null pointer exception? The null pointer exception you are seeing right now occurs not in the method you were testing, but in the other method, in the low method, you see? And this is the moment in which you start screaming. I mean, why? Why in the world do I have to know anything about that other method? I tested it already. Give me a break. Why does this happen? Because you called the low. Because this is how production code is. You called the low. But because that was complex, you already tested in isolation the other method, and you basically don't want this call to happen. This is what you are facing. This is more common in legacy code, in classes of hundreds, thousands lines of code that you don't know yet, but you want to just put your test in some wildness of code, and it will happen to you. You will end up calling a method, and calling that method will force you to basically increase the amount of data you put at the entry of your test. Let me show you how we can work around this error by just enlarging the fixture, the amount of data you throw at your production code. I could just set creation date to some date. I don't care what date. But this line, I don't care what date. This line doesn't have anything to do with the logic you are testing. And it will confuse people later. They will wonder, why do you have to set it now? They will be looking at this method, looking here, and they won't understand what's the connection. Right? leading to basically enlarging object models. We will get to object models. That's another pitfall. It could work up to a certain point, but then there are other dangers with object model. Very good, Peter. Exactly. Oh, Peter! Wait a second. You were Peter. Good. So, hi. This test is green, but it enlarged your fixture. Your fixture. Good. Now let's see. So I don't want to add this extra data to my test. Because of that, I would instead prefer to block the call going downwards. How to do that? Well, Mockito offers us the concept of partial mock by means of the SPY method. When you put SPY on the method, then you can test methods in that class, but at the same time you can, for example, do this. Do nothing. What the heck? Do nothing. What do you mean? Do nothing. Do nothing when the God method here is invoked to the method low with any argument on earth. I don't care. I just want to do nothing. This is also bad. I mean, what the heck is that? Plus the syntax. Very weird syntax. Do nothing when, okay, but yeah, with syntax it's just a matter of habit. But the problem is that you are, in this simple exercise, it's not dramatic, but you can imagine what happens if you are testing this method, calling two other concrete methods, but then that method, you want to block it. It will be very hard later to understand what you are actually testing. Because look, in this test, you are testing the method high and mocking this. In the other test, you are testing the method low. If you never saw this before in your life, then you are a happy man. Or you are working on a green field. In legacy code, it happens. It happens because you want to block a call to go somewhere else. Good. And partial mocks might seem like a good idea, and they are. If you are not very experienced and you are afraid of changing the production code, they are a workaround. They are a way out of that problem. But we are talking here about hints from the design. The tests here are slapping you. Bad design, bad, shitty design, bad design. Why? Let's come back to understand why. Oops, I have to scroll several hundred slides. Separation by layer. There we go. So the problem is that these spies will eventually lead to horrible tests. So we won't understand what you're testing and what you're mocking. Right? Now, the solution here is to, and they actually tell you that, Mockito itself, if you read the documentation carefully, they will tell you, move G in another class. Why? To make it clear what you're testing. And not only that, you will see in a moment. Let's do it first, and then we'll come back and explain more. The solution, so that's one of the most brutal signs from testing. The use of partial mocks is a mistake, and it should be replaced with breaking the production code in two. Breaking the production code in two, leaving the high-level function in one class and low-level function in another class. High-level, low-level. Why do you call it like that, huh? High-level function because this is the coordinator, this is the orchestrator, this is the guy who decides what happens. The low-level function just does one little thing. For example, checks that the date is before some, I don't know, minus month one. It's not 1 month ago. This is doing a low-level thing. This is doing a high-level orchestration thing. The solution is to break between high-level and low-level. Folks, this has to do with single responsibility principle and separation by layers of abstraction. We break the two complex functions into separate classes to acknowledge they are complex and to give them their own place. Right? Public, class, low-level, but not public. Right? And then this low-level class, you just inject it just like this, right? Plain old low. It's good enough. Low. Let's call it low level, right? Low level. And then I will take it normally to the constructor, plain old, and then low level dot low. I said. So basically, we broke the class in two. We left the high-level complexity in one class, and then we moved the low-level complexity in another class, assuming both require 5, 7, 10 tests each, right? How would the tests transform? Well, I will have 2 tests, of course. Because why? Peter will tell you 2 or 3 weeks from now that that you might want to leave them together. But if they are very complex in themselves, if you need 20 tests for this and 10 tests for this, it might be sometimes better to break them into. So please join the next event in our community. You will hear a different opinion. That's best, right? So that's how we learn, by comparing different opinions. Right? Low. And then what do I have to do? I will give up using spy. I will do inject mocks just like usual, and I will say, hey, I need this low level class in here, but this low level class is just a plain old mock, making it clear what you're testing and what you're mocking. Now I can give up this weird syntax and instead move to do the classic when low dot. Okay, that's pretty weird behavior here. Actually, I don't need to do anything here if I look carefully, because low, if you don't do anything for a method in Mockito, it will just happen. But I might want to make sure it was called, so instead I will put a verify at the end. Verify that the low class was invoked, the low method. Okay, I'm not very good with names today, apparently. Low. Let's see, low level class. Low level, but you get the point. And the other class, it will just test the low class. New low level, please. Okay, done. So I have two tests, okay, and I broke the production into. Let's see if I'm able to run both of them. All right, so separation by layers of abstraction. Okay, this way we're going to be out of names for those classes. That's a problem, indeed, Durim. As usual, naming things. There are only two things hard in programming, right? Cache invalidation and naming things. Finding a good name for the low-level class, it will become a challenge sometimes, but that's a useful challenge because it forces you to identify the role of that low-level class, to put a clear name, and it will help you. This is actually how it helps you understand production later better, because the names you put in, not low-level, of course, the names you put. Let's call it. Let's what's that? Order validator. Now you need it, huh? Validator. Done. And that's, let's see what we change. The this. Okay. Nice. This is order validator test. Huh? Now it makes more sense. Why? Because the validator was complex enough to deserve its own class. Good. So whenever so the solution is to break the functionality, the two functions, in two classes, and to put a mock in between. We need to at least consider this always when we are facing partial mocks. And to partial mocks we get because we want to avoid writing heavy overlapping tests. Right? If you call G 8 times from F because you tested F 8 times, you can imagine how many tests break if something changes there. It will break the tests we put on G and those 8 tests for F. Sometimes all of them break. Good. This is called separation by layers of abstraction. You put a high-level abstraction, the high level here, and the low-level functionality in another class. Cool. It's quite sexy. Next one. So this is what we did until here. Next, let's see what comes. Fixture, pronounced fixture. You have to understand to assimilate this word with testing. Test fixture is the sum of external conditions when the tested feature begins to act. So basically, the environment in which you call production. All right? Okay. Now, let me tell you a story. The two functions before, they were calling each other, you know? F calls G. The high level was calling the low level. Cool. This time, they aren't calling each other. They are just sitting there in the same class. Let's see if I'm able to show you first in the code what happens here. I'm not sure if you know what kebab is. This is a very important cultural thing. You have to understand Romania. You have to understand what put one more A. You have to understand this first. To understand Romania, you have to understand images, please. I hope you are not hungry at this moment. So, all right. Now, you can notice here onion. You can notice here cucumber. Some of them contain cucumber. Some of them contain onions or tomatoes or other. Yeah, good. No, nothing to do with the training, but still. Here I have two complex functions sitting one next to another, all right? And they, of course, have tests. Let me get to the test class, and let me put the test class on the right side. So the test is always on the left, the production on the right. This is what I got you used. Right. So kebab test here, dependency. So I'm testing the kebab here. The kebab has two complex functions. It is always about complexity. This is always about complexity. If there is no complexity around, I don't care how you test it. We can test it all together, like Peter will tell you several weeks from now. But if there is high complexity, if these two functions need both to be tested and they sit in the same class, something funny will happen. Let's see. The first function, complex one, and again, because it's complex, it requires many such tests. The first function, complex one, has to have for all those tests, and let me actually duplicate them a bit. Let's make three of them, 1, 2, 3. The rule of three, you know, base. Every time you repeat something three times, you have to extract. The rule from extreme programming. So right now, you saw that I have always to have the right to add onion. I have always to have the right to add onion. It's repeated 3 times. So any reasonable developer should wonder now what to do to reduce duplication. And the answer is pretty straightforward. You can just move it to the before, which runs before every method in this class. Perfect. Job done. Yeah. Good. Like yeah. Done. Perfect. So right now these 3 tests, let me show you. Actually, I will run the whole test class. All the 3 class, all the tests in this class, they work because they don't throw exception. I avoid the if, right, to get to the complex logic. I'm imagining I have to get there 5 times, right? So let's see. If I run the whole suite, Capsalon. I don't know what Capsalon is, but good. They should all be green, but then look what happens. I have to test the second function again, also, the second one. The first one I tested, I have on complex one, I have 3 tests, 5, imagine. They are green, perfect, congratulations. But then the second function has to be tested, complex 2. To test complex 2, I have also to have a lot of, okay, 1, 2, 3, for example. What will happen then? Let me play the game from history like it happened a while ago. Okay, good. People are talking about food. Good. Complex 2 underscore. They also, when testing the complex 2 function, you have again to repeat the stubbing to allow cucumber to be added to the shawarma, to the kebab, to the capsalon. Good. So cucumber 3 times, again 3 times. So the rule should be the same. So let's take it from here and put it somewhere else. Where? In the before. Pam pam. And this is how you add to the before. Stubbing, again, when you teach a method that what to answer in production, it's called stubbing. Okay. So common stubbing for different tests can be added to the before to reduce duplication, which is a good thing, right? Remember, don't repeat yourself, the principle, right? But now you are facing another issue. You have now different tests in the same class. And if one of the tests fails for some reason, you will need to understand why it failed. To understand why this test failed, you have to look at what happened here in the test and also what happened in the before each. At which moment you will have a problem, because you will have to understand what part of the before you need. What part do I need? And that in a large system is pretty impossible to answer sometimes, because yeah, you can imagine, yeah, right? Which of those 8 stubbing do I need for my failed test that I need to debug right now? And this is sometimes impossible to answer. This is why this was a habit in early versions of Mockito. Mockito for several versions already has disabled us to do that. Why? If you now try to run this test as it is, it will not work. Yes, Mike, exactly. That's a very good one. With nested classes. I will show that a bit later. But now here, Cucumber right now doesn't allow you to do that. Why? Because people were doing this a lot. And the guys from Cucumber, from Mockito. I was thinking about Cucumber. The guys from Mockito saw that people were drowning in such befores, endless befores, bloated with. Okay, this is called it's called bloated fixture, right? You end up putting here a lot of stubbing, a lot of setup for all the tests in the test class. Okay, and that's very hard to trace later. This code smell is called fixture creep, right? And it happens when in production, when in the tested code, you have two complex functions that use this joint set of dependencies, or they need completely different fixtures around them. Right? Now, Mockito fortunately disabled us to do that recently, because if you look, it breaks. Why? Mockito, if it sees you stubbed two functions, it expects you called them too. You called both of them from your test. So let's analyze just a single test for simplicity. Complex one. This test, complex one, calls this one, the function above. The function above never wonders about cucumber. It's concerned about onion, not cucumber. And because of that, Mockito cries, saying, "Hey, don't do that. You told me you stubbed this method, but you never used, and it's called unnecessary stubbing exception." Okay. Unfortunately, they also allowed us a way to work around this. Mockito settings, I think it's called. Yeah. Called lenient or strictness lenient, something like that. Good, that's it. And because when they introduced, this was a breaking change in the framework in Mockito. And there were many teams crying when they did that, because they were using this feature. So they had to provide a way to get back to the behavior. But it's a bad idea, because they were doing that for a reason, right? Because the fixtures were not understandable anymore. All right. By the way, if you just want to, this is don't do this. It defeats the purpose. It go against what we are talking about here. But if you want just a single one, there is an alternative for a single method, for a single stubbing. So again, trade-offs. Maybe just once, not everything. Maybe just once, right? So basically, today, if you go in a greenfield, if you start a new project, you should never use this. And maybe sometimes, under certain circumstances, perhaps, but it's still okay, because if you have to understand what this function was relying on, you can look at this and you can say, hey, this might not be needed. At least it tells you. Anyway, so the point is that whenever the before grows big, you have to do something about it. You can't just put in the before input and put stuff inside. Wait, what happens? I have a problem with my mouse. Just a second. Good, very good. All right. So what's the solution? Split the tests. Split the test. Let's split the tests. Let's do it. So I have one test for complex one and one test for complex two. Okay, I can do that. Let's see. So this is kebab. Let's be brutal, shall we? Duplicate. Good. The first one is complex one. In production, to do this, to duplicate 50 lines of code, you will shit yourself. Oh my god. That's why you need practice. Huh? Kebab complex one, I will only be concerned about complex one. Complex one has to do with onion. Good. And I will leave the tests for complex one. The others, out. Complex two, it will only need the stubbing for cucumber. And these functions out. What we ended up with is come on, Control Shift F10, is two separate test classes. It's okay, but you can do even more. You can say, wait. If I broke the tests in two classes, wait a second. Any idea? Do you suspect where I'm going? If I broke the tests in two classes, if I'm testing separately this function from this function, what's the natural continuation to this? Huh? If we were in the room, you would say, break the production! Break the production! Yeah! Break the production! Bravo! I mean, why are they together if they don't have anything to, if they are so complex, why, if they are unrelated, break them. Break them, break them, break them. So, you see, tests exert this pressure to break complexity further. Okay? Kebab too. Because this is what makes the code easier to understand in the end. The goal of writing tests is to simplify your production design. All right? So basically, tests keep slapping you, telling you how bad design you have. So if you try to write fine-grained unit tests, you won't survive to write tests if your design is shitty, right? So it increases friction with careless design. Okay. So let's go back here. So here we are. I have two production classes broke down into pieces. Very cool. Very cool. Why? Because Mockito, lenient. Because picture creep. Good. Now, there is also another point that, where are you? Mike suggested. It's called nested hierarchical fixtures. If you never saw this before, grab something tight. It goes like this. Let me see if I can show you. Is it here? Design hints. 1 second. I don't see it here. No, it's in a different project. Don't. In a second. In a second. It's right here, prepared for you. Yeah, here it is. In a second. It's called. I'm a master. Good. So, just a moment. I don't see it. Was nested fixture? I will just run this once. It's not basically. I'm not planning to explain 100%. I'm just trying to sketch a bit. So we have Mockito, right? I have this extension that you can look later if you want. I will give you the link to this if you want to explore this. It's Git. No, how do I get to the link of that file? GitHub something, I forgot. Git, where are you? Git. There was a way to get actually the, I don't see it right now. It's called custom create. I will at least give you the gist. That's that I can do very easy. Gist. All right. Here I will paste it in the chat. Good. Doesn't work. Just watch it, and you can Google. Look at what happens if you run it. Given a valid customer, and then I expand. What do you mean I expand? And this is on Jenkins, right? Given a valid customer, fail if another customer with the same email exists. So when you create a customer, create customer should, given a valid customer, fail if another customer with the same name exists, with the same email exists. And then another condition based on the same branch here. If it's valid, send a welcome email. And then yet one more test. If that country of the customer is discounted, then it should receive a coupon. And the coupon should be for the category home and electronics. What the hell? So nested, the key part here is that you have some mocking and stubbing done at the top level here. And then you dive into more nested scenarios inside. Taking advantage about of the stuff you did before. So both of them rely on this common part, but they themselves add more stuff. So if this is valid, stuff, and at some point one more nested in the valid. Pretty wild. You see? Right, nested. Someone mentioned. Okay, but again, not really my goal. No. Right. Next point. So you understand, when the before gets ugly and big, break the test, break the production. At least think about doing it. Sometimes you will be scared. You will be afraid to do that. Now we're getting close to what's really painful for us. You implement a feature or a change in your code, and it works. Congratulations, Well, bravo. Yeah, bravo. But then you write unit tests because you have to write unit tests. And then you blindly mock all dependencies. Half of you, at least half of you do this. That's one of the parts, Mark. Look, if something is not clear and you want to continue discussing with me, this is my email in Zoom, right? I can't paste it on YouTube, but in Zoom it's there. Okay. Google me. You can email me. Peter is. How about TDD? Good one. No, Peter. Peter knows better than me that TDD. You are very lucky. And if you are, I mean, kudos, bravo. What's the problem? If you finish the stuff and you tested it with your mouse and it works, and then you have to write unit tests. Of course, you want to get the job done as fast as possible. You want to write those tests as fast as possible. So the easiest way, you just you call the production code by mocking all the dependencies of your class. And then 2 years later, you complain that your tests are fragile and they slow you down. Of course they slow you down, because you just wanted to get the job done as fast as possible. Anything in life you want to get done as fast as possible and you don't stop and think, of course they will hurt you back later. So this is a bad habit. Now, 2004 for Christ's sake. And that's an article just like the one in PhD, just like an article, you know? These guys invented mocks. And they were saying in 2004, what's that? 18 years ago? What's that? It's insane. They were saying, don't just mock dependencies, mock roles. What the heck is that? What do they mean? They are trying to warn you about this habit that we are now doing. Every one of us is doing this. They were trying to warn you that before mocking a dependency, you should clarify what's the responsibility of that thing you're mocking. Because if you did not mock, if you did not crystallize the role, if you don't know what that thing is doing, mocking it will kill you later. Why? Because if the responsibility is not well settled, if it's not well defined, it will fluctuate. And every time the mocked API fluctuates, your tests break. And you know what I mean here. If you ever were in a project with several hundreds or thousands of tests and you want to refactor something, you know perfectly well what I'm talking about here. The moment you want to refactor some method, and that method is both tested and mocked, okay? That leads to very fragile tests. Why? Because you didn't double check what is the role of that thing you are mocking. Okay, I know it's hard. This is the most difficult to understand, really. But let's give it a shot. It's a bit stretched, the example. It's a bit super overly simplified, but yeah, let's give it a shot. You have here a parcel facade. Good. The parcel facade is here, and the test for this class is on the other side. Oh, just 1 second. Done. So test here, production here. Good. So what happens? Let me just have. Where is my Chrome? Did my Chrome just die? No. I have streamed here. Okay. So let's go in the code. And this is a test. At the first look, you already have this feeling. When, verify. What the hell is going on here? Now, someone wrote the function, and then at the end, called the function from tests, but to do that, it copied all the dependencies from here into the test and put mock, everything. Now, let's try to reason about the role of this class. What the heck is it? What's the role of the parcel facade? And let's just inspect again the production code. Let's see. If display service, display tracking number, where on some device, on some, I don't know exactly how, but I call this. And then if the parcel is a postal package, right? If the parcel is part of a composite shipment, display a warning like this in the interface somewhere on some device. Good, these two. And what am I doing in my stuff? I am saying verify display AVB, and then verify display multi-parcel warning. I'm checking both of them because I took care to make it a composite shipment. And is anything fishy? Do you feel anything fishy in here? Is there anything strange about this scenario? So the parcel facade looks at the parcel, displays the tracking number somewhere, and then if the parcel is composite, it also displays a multi-parcel warning. Think. Whose role, whose responsibility is this? Okay, time is short, so I'll press you a bit. Look, why am I doing this? Isn't this the role of the display service itself? I'm talking about this if. Why am I doing this? Why am I doing this? Because it was late, and that's where I thought to put the if when I had to add it 2 years later. But that's not what the if should be. It should be inside the display AVB. Let me give it a shot. I will cut it from here, move it inside display AVB. Here. This is where it should be, right? But of course, this requires a bit of refactoring because I need to pass the whole parcel inside. Okay, change like this. And now, given I have the parcel, I can get from the parcel the barcode, and I can get barcode, and I can call my own method in here. What did I do? I shifted the responsibility. I said, you, display service, it's your responsibility to display the multi-parcel warning if the parcel is composite, not my responsibility in the parcel facade. I delegated the responsibility to that guy, right? Because it's better suited in there. I told you this is pretty subtle. It's display. It's something that has to do with the display. Right? Applying single responsibility principle. This is its job, not the parcel's job. Right? Ay. So, and this also allows me to make it private. I'm not entirely sure I can, but you see, at least it reduced the number of interactions I have to verify on my facade. It shifted. Dream, right? I passed the parcel, and parcel is mutable, and then who knows what can happen in there. So I know there is this risk, and you have to have in the culture of the team never to mutate parameters. I know, or make it immutable. Yeah, it's similar to how I moved the low function, exactly. It's similar, the same idea, separate by layers of abstraction. I'm doing this, and that's its responsibility. Move it out. So what do I have to do? I just have to verify a single. It disappears one verification. Huh? Yes, Mike, that's the trade-off. Excellent, Mike. Mike just saw that there is not just green and happy everywhere. There is a price to pay. I had to pass a complex structure inside a method instead of just a single AVB. That's the price. Indeed, trade-offs. But tests are supposed to make us think, not to give us blind answers. No one gives you blind answers. You were adults, right? Good. Very good, Mike. Exactly that's the trade-off. Very good. Now, next thing, platform service add parcel. Good. And then tracking provider repository find by tracking number. What? A tracking provider. And then tracking service mark departing warehouse for those tracking providers. Let me just look at these two things here. In the parcel facade, I say tracking provider repo, and then tracking provider repo, and then tracking service. What I will do, I'm not sure if you agree with this actually, but look, this has to do with tracking, right? Not parcel. So one idea would be to move this call inside the function in the tracking service. Here. To push the repo inside, the tracking provider repo inside. My mouse gets out of battery slowly. So, probably find a tracking provider repo. tracking provider report. This should be the name. Yes, please. Tracking provider report. Thank you. And of course, my dear, or let's not use Lombok today. Okay, good. The day without Lombok, the day without Lombok. And then the parcel, I have to provide the parcel instead. Okay, tracking providers, I don't need the argument anymore. Save delete. But I have to get the parcel in. So from where I call it, I have just to pass the whole parcel. Again, Mike will say, hey, wait, this is complex structure. Yes. Good, very good. This is it. Good. Parcel AVB, and then again parcel AVB. Then and then what happens in testing the facade? I don't need to have the repository at all. And you see, I can delete the repository. And then what? I don't need the repository here either. That's cool. One less dependency of my facade. I just shake a bit of the responsibilities, basically, right? And then wait. Yeah, this out. Good. So before you mock something, we look very careful about the roles involved. Right? Mocking is another shot, is another opportunity to review the responsibilities of your design. Don't just blindly mock stuff. Now, feature envy code smell. Not quite. Feature envy would mean to put behavior inside the data object. It feels like, but I think it's better said as single responsibility or separation of concerns, some people call it. Anyway, good. Now, are you familiar with the testing pyramid? I send you a link. I won't explain everything. How do you treat the dependencies implementation that are private, auto-wired by interface? Ooh la la. Ooh la la. Dan, that's a very good question. Dan, if you can you stay a bit after the top of the hour? I will answer this after in the Q&A discussion brainstorm. Very good question. Please, if you can stay, it will be very good. Now, to keep here on the track, the testing pyramid. We have unit tests. Many of them have integration tests, which test multiple objects, perhaps with the database involved, and we have system tests that test everything, or ecosystem tests that test the flow end to end. This is the pyramid. Testing pyramid. The reality in many companies, however, is the ice cream cone. This is supposed to be funny, but many companies, included I have clients that have a department of Q&A of 30 manual testers and several hundred unit tests. That's it. So the reality in legacy is sometimes completely different. But now, this is like huge legacy monolith that you inherited. This is the theory. And now something new on the block is the so-called honeycomb testing strategy. Where am I starting from? Just look again at this code. This code has 1, 2, 3, 4 lines of code. The test has 8 plus these. What the heck? I won't count these. It's much larger. And for what? I mean, some people will ask here, what are you testing here again? No? They will ask you, what are you testing? Now, it is a good policy, a good habit in development teams, to write unit tests for everything they implement. It's a good habit. The problem is that unit tests is often considered to represent testing each method in isolation, or at least each class. That's a problem. That's a problem if your method is not complex enough. This method does not deserve a unit test, some people will say. What? Anarchy! Anarchy! Right? Anarchy! You will feel that at some point. What am I testing here again? Especially if you join a team very dedicated to writing unit tests. If you are fortunate to be in such a team, you will end up in this scenario, looking at some tests and wondering, what the hell was I testing here again? Only mock. Now, some people will say, don't test anything. Burn the test. Blame the author, kill the author. No. Others will say, yeah, maybe shift a bit the production design. Why do you have such stupid methods in place? Do you really need that thing at all? But another idea is not to unit test this method in isolation with mocks around, but to integration test it down to a database. What? Introducing Introducing the honeycomb microservice testing strategy. What the heck is that? You see, if you assimilate with the previous two shapes, this is the integrated test, like end-to-end. Imagine microservices talking to each other, all of the ecosystem, maybe put in Docker, I don't care. This is the unit tests that rely on mocks, or maybe without mocks if you write pure functions, if you are strong. In between, this relies on Spring Boot tests with test containers and wire mocks to basically make your test repeatable. Databases in test containers and wire mocks for integration with other microservices. And what's this strategy trying to say? Google this, honeycomb microservice. It's trying to tell you that every use case should be tested at first, end-to-end. From what? From your web endpoint, with the real database put in a nice whale somewhere, right, in Docker, and with wire mock next to you. And you write as many such integration tests you can. 2, 3, 5, 4, 7. And there is still complexity that you didn't get to test. Only then you rely into implementation tests. What do you mean? If you have some very weird business rule with 7, 15 branches, you can't reasonably test it by just firing JSONs at a web endpoint. You can't. It's cumbersome. So instead, you take it with you, you decouple a pure function out of that use case, and you unleash hell, right? With tests on pure functions, ideally with 0 or very few mocks. Now, of course, the boss won't be happy yet because it wants to make sure that the checkout flow is really working. The checkout flow. So they will ask you for some end-to-end tests to make sure that the main flow work no matter what, right? During that's the battle. That's exactly the battle. If you write so many integration tests with Spring Boot tests, these are famously slow. But you get to hardcore stuff like parallelization, Spring Boot tests, slice tests, context caching. Context caching happens, but you have to tune it. Exactly, Georgia knows. There are tricks you need to do to speed up your integration tests, and the goal is to run all your Spring Boot tests in less than 10 minutes. If you can do that, you can run them after each commit, maybe 15, not 2 hours, right? And the usable containers, like to make sure your containers remain alive. It's still to study, but this is the trend I'm seeing in top companies. Good. Good. I am still not done. Damn it. Look, let me push it a bit more. I have one more problem to show you, but still I have an issue here. Doesn't compile for some strange reason. It's parcel I think here. Now one thing more, please. Should I do a third episode? Okay. No, I have 10 minutes more to explain. We have 2 things to test. Generating invoices, production is on the right, always. And my test is on the left. This is the rule for today. So here, this is the test I said there. Good. This is the tested code. This is what I'm testing. Estimate shipping costs. This function, right? This function. Okay, I put a breakpoint here. Okay, this function and this function. Now, the 2 functions, they both take customer. And you can imagine they both take customer. This one has to know where the guy lives. This guy has to know how to invoice him. Good. Now, if they both take customer, you will have a problem. To generate the invoice, I will extract some information from the customer, the billing address, right? To test the invoicing flow, I will have to set a billing address. To test the estimation shipping cost, I will have to set the shipping address. So I have a large object for which I have to set some fields in one place, other fields in another place. The problem, if there are only 2 fields like this, I don't have a problem. But if there are 7 fields here and 5 fields here, you will definitely lead to what someone called object mother. let's do that. In the test folder, I will create a class, object mother. Don't think I'm inventing words here. Google this. Is a pattern. Object mother pattern. Google. And this object mother will contain ways to create customers initialized with everything. So why? Because you don't want to instantiate the customer with 7 attributes here and 5 attributes here. I mean, putting seven useless attributes in a class just to be able to get the customer out, it's very annoying. This happens especially when you go for immutable entities. When your data structures are immutable, you will have to provide all the fields, right? But that's bad because it's a lot of fields. So let's do it. That will be a customer, and that a customer will move. Let me make it first a static function, static, thank you, and then make it public, and then move it out. You move where? To the object mother, okay, and good, and the same, I will call it from here, a customer, because it's now like a global factory of test data. It's reusable, bravo, but the problem is it couples the tests together. So object mother is very common. The idea to create test objects and then reuse them is very common, but it has a problem. Imagine someday one guy comes here and for some reason, look, changes something here. Change. By the way, do my tests still work? I don't think so, because for generating the invoice, I have to take the standard customer. Look, I will tell you two tactics, two approaches. One approach is every time you have to have some data inside the customer, you will go here and put your data. But the problem is that if everyone does this, at some point there will be 2 tests, right? You can see where I'm going. There will be 2 tests. Let me see, not invoicing, not shipping, but actually print shipping slip. You know, the stamp, print shipping slip. And that print shipping slip will, let's imagine, I don't have the test that, look, since time is running out, here is a production code. In the production code, I will take, to print the slipping, the print slip, I will take the shipping address, and this is what, and I will make it uppercase to do some logic to uppercase, because on the shipping slip, it's in uppercase always. That's really the case. Good. And the shipping address is this, and then I will say, okay, this has to be equal to, and I expect to have here shipping address. To do that, I have the customer to have the shipping as shipping address. And I go to the same common shared factory, where is it? Here. And I say, oh, I have to have here shipping, and I will put it very carefully in lowercase to test the uppercase. Next thing you know, when you run the 2 tests, I'm not running the right one. When you run the 2 tests, what will happen? I think you see it, right? If you run the 2 tests, 1 and 2, I just changed the data on which this other test was relying on. Right? I mistakenly broke the other test because I changed the shared object mother. That's the problem with object mother, creepy object mother. So you use large data structures in your core logic, and if the structures enforce their internal consistency, or if they are immutable, then creating test data instances becomes cumbersome. So you end up sharing a test data class that builds correct instances, right? And then the test data gets bloated and couples your tests together. It's recorded and live streamed. Yes, I will paste the link afterwards. It's already on the community event. So then what should you do? There are several options here. Look, print shipping slip, but why is it breaking? Just a second. I think I am not paying attention, right? Billing address, shipping, print shipping slip, expected shipping. What's wrong? And oh, damn it. That's billing address. This is what I wanted to shipping. Okay, that's I've changed the wrong one. Good. So technically, one idea is to break the test data and to create multiple such. But maybe a better workaround is to start from a from a, look, you see, start from a standard customer and then tweak it in the way you want. So look, let me redo the last change. I shouldn't have gone here and changed stuff. But instead, if I want Romania, if I want this customer to have this shipping value, I will do set shipping address shipping here. I start from a so the rule is in the test object, in the object model, you never change anything. You just add. Or test builders. And there is a discussion which I almost agree. Test object mother versus test data builders. Exactly. This is it. Give it a read. It's very good. So object mothers like this are a bit weird because they couple tests together, and then you will break stuff that you don't know of. All right, we're getting very close to the end. Actually, that's the end. I skipped one. It was about onion architecture. So let's be fair. Let's do that. Look, there won't be any code for this. no, Partri, please come on. What am I doing? No, I'm supposed to let others speak. Problem. You allow external APIs. You use external APIs in your core logic, where your complexity is. And then if you want to test your core logic, what am I talking about? Imagine like a business function in a service. And in that function, you call some API and you get a DTO and you work with that DTO inside your function, inside your core logic. You are violating onion architecture hexagonals. You are not doing domain-driven design. You are just manipulating DTOs. There are excuses for this, of course. There are valid reasons for this. But the problem is that if you have complexity in an application, you shouldn't be playing with external data structures in your core logic. Never. But instead, you should decouple external APIs with adapters. What's the connection to what we're talking here? Look, the domain that you have, you will decouple from anything outside. You will decouple from the API that you expose to others. You will decouple from APIs that you consume from others. Your domain should only speak, your complexity should only speak the data structures that you created in your domain objects, your entities and value objects. So what's the connection with testing? Look, if you want to test, this is where the bugs are. This is where the changes are. This is where headaches are. This is where 200 tests, 2000 tests will be. Tests on the surroundings will be some, I don't know, several hundreds, but not thousands. What's the idea here? You don't want to write 2000 tests using DTOs coming from someone else. It's bad. Because those DTOs can change, are ugly, speak a different language than you, a different ubiquitous language. It's not correct. So what you do, you put an adapter. You put an adapter and you mock here. This is where you mock. And you start here, testing your logic. So the point is, in your test, you should not involve DTOs, neither in parameters, neither in mocking and stubbing. In general, okay? In general. If you have to test something from here, why don't you fire a test? Of course, there are excuses everywhere. There are excuses, but the most of your tests, the largest majority, the majority, should be tested by just working with your data structures, with your domain objects. Done. Recap. Yay! Boom. Recap. What did we do? We said, the more you call production code from your tests, the better signatures you will have and the better skills you will acquire, trust me. Immutable objects rock, I don't need to tell you that. Command query separation, I skipped the recap, I didn't recap this, but the point is a function should either return new values or should do changes, side effects. Watch the previous part. The more tests you have for some part of code, the less mocks you should involve. That leads directly to writing pure functions or isolating a functional core, a pure functional core in the middle where complexity is. taking complexity into functions that just take arguments, return values. A pleasure to test. Partial mocks should immediately lead to breaking the production code. Okay? Do not tolerate large functions in the same class that require each dozens of tests calling each other. They are different layers of complexity, different levels of abstraction. Okay, break. If the fixture gets too big, okay, you should break the test class at least, or nested classes. And maybe then think about breaking production. Think, not always. So I have cases in which you have production class with, I don't know, 100 lines of code. And then we have 3 or 4 test classes with 50 lines each, testing that production. This can happen, it's not bad. But if it might be okay at some point. Mock roles, not objects. Meaning that you should not just blindly mock all the dependencies after you finish the implementation. Think about what is supposed to do that thing. And shift a bit the roles. You need common sense here. You need some reread and try to understand the design before you just mock stuff. Keep tests speaking the language of your domain. If you feel like you are not really testing anything, maybe remove that layer that you were testing, or maybe go for more longer tests that start from web and end up in the database, which of course lives in a beautiful whale in a Docker. And there are some wire mocks around here, probably sometimes. Good. And if the object model goes too big, break the data objects into smaller pieces, break the object model into smaller pieces. And there was a very horror question here. I will try to formulate. If you have a customer with 7 arguments, with 7 fields for shipping and 8 fields for billing, why do you have a single object? Why don't you have shipping or customer shipping, customer billing, 2 objects? And maybe break the whole application into 2 subdomains, bounded contexts. If you understood what I said, you will go. If you didn't, you will go. Maybe an object with 20 fields in which you set 10 fields every time for some use cases and other 10 fields for those use cases. Perhaps that 20 fields object should be broken into shipping customer, billing customer, or customer shipping info, customer billing details. Breaking data objects in pieces is probably the most difficult refactoring in the world. Good. So the conclusion: you should cover more logic with automated tests, repeatable automated tests. I don't care what exactly you use, Docker or not, test containers or not, WireMock or contract-based tests. I don't care, Mockito, I don't care. Automated, isolated, okay? And do that earlier. Do that earlier, because that will protect you from introducing bugs later. That will make your boss happier. But that will give you courage to refactor, and you will get to cleaner code. You knew that. If you're not afraid to break things, you will refactor more aggressively. Right? But the point of this training workshop was it will give you more feedback early when you still can change stuff, when you still have your design in your mind and you have a chance to twist it. If you come back after 2 years and try to test it, or later, on Monday, if you do it Monday, the magic is gone. It's harder, much harder. Right? So it exerts a very high pressure to break complexity, because tests put pressure on where the cyclomatic complexity is, where the branches are, where the different flows happen. If you have boring methods, they don't matter. You can test them whatever you want, however you want. That doesn't care. Tests will insist on places in which you have branches and complexity. And writing tests earlier will also increase your programming skills, I promise, and that will lead to more good. And one last slide, you don't need approvals to write more tests. Do it tomorrow. Huh? Tomorrow I will stop drinking, I will stop smoking. Tomorrow morning, start writing more tests. Have to be motivational. Yeah. Good. Yes, thank you. And then there is a discussion. From Dan. How do you treat the so if you want to formulate some questions, shoot. I will stay as long as I need to. Always write more tests. That's the word. And then 1-2 years later, come back and delete half of them. But doesn't matter. You should write more tests. You will delete half of them because of what Peter will tell you in several weeks from now. Write bigger tests instead of fine-grained. Come and see that one. It's very good. How do you treat the dependencies implementations that are private? Auto-wired by interface. Auto-wired by interface. Wow. Do you go with integration tests? Or you try to find the public theme factories? Auto-wired by I need more input here to understand what you're trying to say. So I have a class which is 2 tests, and I have a private some dependency which is auto-wired. And you are concerned about the private word? If you are concerned about the private word, I have a good news for you. Mockito doesn't care about that. Let me show you. Let me show you something we did. Here. I don't think that's what you meant, but let's give it a shot. Perhaps this will clarify something for others. Auto-wired. If you use auto-wired like this and the fields are private and you don't have access to them, apparently, Mockito doesn't care. Mockito will still work. Because Mockito, like Spring, like Hibernate, they don't give a shit about private. Perhaps that's not. Oh, Dan, you are in Zoom now. Okay, good. You are in Zoom. Okay. Package A has a service. Let's see that. Package A, welcome to my room, has a service. Okay. All right. And then the implementation is private in another package. Shit. You mock the interface. Why not? That's more like it. That's more like it. That's more like it. So display service is in a different package. Let's try to make it. I will put it here. Good. And display service has an interface in front. Let's do that. Interface. All right. With both methods. Extract interface. Good. With I in the front. Okay. Yes. Yes. The point is now I can inject in my production code here. I can inject production code for facade here. I can inject I. And then what he says is that the implementation is package protected. Who does that? If you have this situation, then you can just mock the interface. What stops you from doing that? Or perhaps I'm missing something. So you can avoid using Spring Boot tests. You can just mock the interface. That works. Let's give it a shot. Let me also check that I don't see the D. Let's see. Display service. Is it visible? How come it's visible? I'm in. Oh, display service. I didn't move the display service apparently. Display service. Come on, where are you? Display service. Yeah, I should move this out. Here. What am I doing? Interface is outside. This is outside. Oh, I should put it somewhere weird. Yeah, continue. That's more like it. And the test. Okay, that's I. And it should work now. Parts of facade. All right. Good. Okay. Find theme for Hibernate validator factory. Oh, yeah. So Dan mentioned a word very important for testing. It's called themes. Places where you can decouple the design. But I would avoid introducing too many themes just for some. I mean, that's the last resort. Don't introduce new classes just to be able to sweep in some implementation. But this works. Perhaps I'm not seeing it. Okay. Can also start a small Spring context scope. Yes, but Spring context, could work, but it's much more time indeed. Yes, I think we should. It's 20 minutes extra. It's okay. All right. Any other questions, ideas? challenges. I hope you didn't agree with everything I said. Kapsalon, I will. Okay, 10 more seconds for questions. If not, we'll end this. Goes well with the beer. And I was taught by some group in Netherlands that this is a small beer. This is a big beer. This is too big. There was a. Don't you lose a lot of design hints? Excellent, Mihai. Perfect. Perfect, Mihai. Mihai proved to me that he combined everything I explained and he was able to come with a very cool. He mixed everything I discussed with you. And she said, "Okay, good. So you told me that at the end, writing many fine-grained tests like these at the bottom will give you more design hints. If you write integration tests like black box end to web to database." Paul, I will answer this in a second. Git link, I will paste. Just a second. If you write more of these, you will miss some in design enhance. True. But if the use case and 80% of use cases are very stupid, are very trivial, I dare to say. Many get, maybe even a create, it's easy sometimes. So those 80% stupid use cases, you don't need design hints. You can write anything you want, I don't care. The danger is very low. But for those heavy use cases that contain thousands of lines of code in a single click, those you need as much design hints you need. And that's where you will anyway get the implementation detail tests, like Mockito and fine-grained. So that's the magic. The tests will focus you on those places that really deserve your focus. Very, very cool question, Mihai. Thanks so much. That's exactly that's how it. Paul, it's recorded, so I will be kind in my remarks about Igor. Extreme opinions, two extreme opinions. Attracts by charm, but in practice will freak everyone out. I tried. It freaks everyone out. And I will put the link to the Git here. It's also in the in the meetup page, but I will paste it in here. And mind the branch name. It's in here. And this is the if you watch the recording, type it. I will paste it right now in your chat in both live code and. So nice to read, nice to understand what Igor is talking about, but use your own judgment, really. Yeah. Trick. If you ever go to a beer, I will tell you more. Good. It will be a trade-off again, right? Probably only makes sense to consider the happy path in the integration layer. Yes, you start from the happy path and you write as many branches you reasonably can without exploding the test at the beginning, without having huge fixtures and long tests. Right? If you are able to cover all the 10 branches, I'm super happy. Why not? Go. There is one other trade-off, but it's too much already for a single day, about writing a custom testing framework. That's another story. Okay, good. 10 seconds. Time to ask. 10 seconds. Let's see. 10 seconds. 10, 9, 8. My wife is at the door anyway, so good. See you. Time's up. See you soon, several weeks from now, and I will fire a mass mail to the community for those 3 free licenses from JetBrains right now in a couple of hours. Good. See you. Have a nice day. Bye bye. Okay, so end stream.